Thank you for having me here. I'm not going to be quite as polished. I will freely admit I finished this presentation at about 5 o'clock. So if I stumble coming through here, bear with me. Hopefully I'll get to some good data for you guys. So who's this Chris guy? I'm an advisor and a consultant at Scalar. Scalar is a high-speed log management and metrics aggregation platform, right? So built actually by the team that built Google Docs. And kind of grew out of Steve Newman, our founder CEO's pain of dealing with large-scale backends. And so very high-speed aggregation and input. Is it specific to serverless? No, to be honest, right? We'll take data from anywhere. But it solves a lot of challenges that you start experiencing as you go through this migration from a traditional architecture to a more serverless architecture. And I'll kind of touch on that here in a bit. So what are we talking about here? So logging and debugging at scale. Everybody knows how to log and debug, right? I mean, that's not terribly complicated if you're working on a single system, if you've got a couple of requests per second coming in. So at scale, what we're really looking at doing is how do we do that efficiently when we've got just massive amounts of data, when your use cases are a little funky at times, right? You got some misbehaving clients, right? So as I put it up here, so how do we understand it under load, right? And how do we isolate real-world problems, right? This isn't something that you happen to write a unit test for. This isn't something that your QA team thought to go run. What I'm not going to go through here is, here's your 7 steps to success. Do these things, and rainbows and unicorns will appear in the serverless world. This is a guide on thoughts and concepts that you can take back on how, when you start debugging and planning out your deployments at scale, through this architectural shift, and kind of understand that. So, to that end, useful, as we talked about last time, kind of the evolution of the OS. I'm going to talk a little bit of the evolution of an architecture for an application, right? So, mainframes. The web never really had mainframes in a classic sense, but I don't know what else to call the Sun E4500s that we ran 15, 20 years ago, and every single user would come in and they'd hit that one server, right? And behind that one server, we had one database. Then we got this fancy new technology that we thought was really cool. It's called a load balancer, right? So now we can start splitting this load up. And over time, we have VMs, and we could spread this roll out. And now we're deconstructing that same concept into containers and VMs, right? We're still doing basically the same work, but how we're composing everything is getting different. So what we're gaining flexibility on the development side, right? We're getting speed on the development side. What this cost is operational and systems complexity, right? There's more moving parts that we have to go figure out. We have to know where things are hiding in the wheels. And so this is kind of a more of a visual representation, right? So if you're looking at that first image, how you debug, that's pretty straightforward, right? I've only got 2 options of where my bug is, right? It's either in server A or it's in my database. Really straightforward. I know where I'm going to go look for my logs. I know what metrics I'm probably going to need. As we move forward, still not too bad, right? Maybe I've got a few pools of servers. I've got a couple of databases, right? This is still relatively comprehensible for an average person, right, who doesn't necessarily know the actual intricacies of everything. And then if we get to the edge here, the most complicated one, right? We've got multiple load balancers coming in. We've probably got load balancers going out to remote servers. We've got maybe multiple external cloud services we're consuming. We've got queues internally. We've got, still have those pools just like we did before, so we haven't actually gotten rid of any of that stuff. Now we've probably got something like this just chunk of code that's running in maybe Kubeless or Lambda or whatever you're looking at. We're consuming databases not as servers, but maybe as just a straight up table view, right? And we still have all of our old stuff. So now, if I have a bug and I've got a bad user that comes in, right? First case, I would just go to the web server because I knew it was in logs, right? And if that CPU was spiked, we're good to go, all right? The second case, maybe, okay, it's which web server, if old like me and doing this for a while, you'd put, little breadcrumbs in the actual source code that would tell me which web server it was on, right? And I could go nail down the one web server. I could use similar tools. If I'm in the current world and I've got 3 services of mine internally, minimum, I've got 2 external services. I know that one service internally that used to be all running locally on one machine has now been, microserviced and is now 14 other services, getting stuck back together. I don't have those same breadcrumbs, right? And I've got much larger data set to kind of go grind through to actually go find a root cause. So as these change, right, we're getting this massive increase in the system complexity, right? The application probably also getting more complicated in some ways, right? Our interactions are getting it. But the operational system, the architecture, massively more complicated. Our troubleshooting and our debugging is starting to shift, right? And at one end of the spectrum, in the old school traditional stuff, right? We're looking inside of a single process, right? And figuring out what's going inside of there. That's where we're focusing our efforts. And when we go to the far end of the spectrum of microservices and serverless architecture, right? Almost all of what we're debugging is actually system interactions, right? Those points where you've got code A running here and code B running there, and team A did a release and then team B did a release, and oops, right? Our APIs are no longer compatible, right? Oh, what do you mean that I was expecting you to type that data this way, right? And you gave it to me that way. So tracing these interactions through the systems, being able to get a single pane of glass becomes more and more important. And then there's the challenge that if you don't catch it and go look at it right then, if you're an ephemeral container, your logs might be gone, right? You may have just lost that data, right? From the old school world, that was a long-running instance. If you guys are familiar with the concept of, herd animals versus pets, right? People heard that concept before? Yes, I'm seeing a couple of head nods, right? So they were all pets before, right? You do everything you could to keep them alive. Now, it's misbehaving, it's sick. Shoot it in the head, right? Get it out of the herd, right? Get that herd healthy. But that means that you may not actually have known what was wrong there unless you've pulled that data off into some central repository, right? So kind of the first takeaway, right, is the highlighted line there at the bottom, right? So as you are contemplating or working on this shift to microservices, serverless, right, ephemeral containers, whatever that evolution is looking for, right, realize where your debugging efforts are going to shift from and shift to, right? And that's going to change some of the stuff that you want to do inside of your code and how you're looking from an operations visibility point of view at your environments. So when you look at an operations environment, you really only have 2 data sources, right? And these get composed in all sorts of really cool ways like New Relic and in other places. But really, you're looking at logs, and logs are just a textual representation of what has happened when it's happened, right? And you have metrics. Metrics are numerical representations of your counts and your utilization levels, right? Depending on how you stick those back together, you're going to be able to slice and dice your environment and see what is going on. One of the key things to be aware of is that they're not always 100% distinct, right? I can count my log messages, right? I can probably figure out how to embed error codes in a metric, right, and give me some more contextual information on what the heck just actually broke with the numerical value, right? So they're not, I've oversimplified here a little bit, they're not totally independent. And one of the cool things that I I like because it simplifies my life as an ops person. I can write metrics to my logs, right? This is also good. It simplifies, my life. I don't have to get as many data pipes kind of coming back off the servers. So this is kind of where we're going to start with, right? And so now, if we take these two data sources, and we know these are sources of truth, right? As we're trying to figure out when we've got 10 million requests coming in every 60 seconds, right? That's big, right? That's one of my larger environments. It's about equivalent to what Twitter does on their tweet gateways, right? What does it actually mean from a logging and metrics backend? How does that actually change what you need in your code? So on the logging side, so collect all the data you need for debugging. That's relatively obvious, right? The challenge is you only want to connect the data that you need for debugging. That's not always obvious, and we'll kind of dive into that more in a second. The other thing that's actually interesting is if you're doing 10 million requests every minute, and you have a 0.01% error rate, how many errors are you going to have in 30 minutes? I don't know, but the answer is a lot, right? So you don't necessarily need 100% fidelity on getting every message coming out of your logs, right? If you are sampling 10% of your logs and you're getting a good sample across it, right? And by good sample, I don't mean, I've got a long-running system, right? And I'm sampling 1 out of 10 systems. So 9 out of my 10 long-running systems are flying blind. That's probably not going to go well, right? If, on the other hand, you can actually say 1 out of 10 of my requests across all systems, I'm getting the logs out of that, you've got visibility into everything that's happening, and you've got a 90% reduction in the amount of data that you're going back through. Doesn't always work, right? But as you get to large scales, and some of scalers, some of our customers are in the petabytes per day in types of log volume, right? At that point, there are certain classes of log messages, and again, I'll dive into more of the details of this in a second, that you can do that type of sampling over the top of. And then the third one is hopefully relatively obvious. Not all logs are created equal, right? If I have my security event logs, right, I may have some retention on that. If I have payment logs that are now subject to SOX or some other financial control, right, that has a different retention than the information or debug level logs that I want for 72 hours post-deployment, right? Thankfully, the short-term stuff tends to be bigger. The long-term stuff tends to be smaller, but you have to build into your system the ability to filter that out, right? If I were to do at scale everything at that debug level, your CFO is probably going to take you out back and you're not going to come back into the office because the company simply cannot afford to store that data. So as you are building your logging, tagging your data, be aware of how it's going to be used. So, and this kind of comes into, back to the first point is, only what you need, but all of what you need. And that's probably the most common question that I get if I'm talking to people at shows or whatnot, which is, hey, you guys do logging? What should I log? Well, I don't know. What's your app? Right? What's your architecture? Figuring that out is critical, but it's not always obvious, right? So a couple of things you can do to kind of go through that process. One, it's not a decision of one person, right? It is a decision of multiple people to figure out what those individual people, those teams, those requirements are on the data. Typically, your two biggest, and I'm kind of grouping these together because they're similar use cases, your application and operations support teams. DevOps, SREs, right? General developers, right? The people who are dealing with the code and the infrastructure and debugging shit that's broken, right? The other one is your compliance and security teams, right? So everyone's here probably heard of GDPR, right? That has a completely different set of requirements, right? Or if you have PCI, completely different set of requirements from your security and your compliance team, right? Be aware. Maybe one tool solves both. Maybe you don't. Maybe one access pattern is good for both teams. Maybe you don't. Typically, they're not the same, right? So big law of averages. If you are an application operations support person, do you care about data from 6 months ago? No, right? I've done 14 releases since then. That data to me is effectively useless. If you're a compliance and security person, do you care about that data? Oh, heck yeah, right? If you can't answer that question, you may fail your audit. If you fail your PCI audit, if you fail, a SOC 2 audit, right, that can have real material impact on your company. Now, access patterns are also tend to be different. If you are in that app and operations bucket, how often are you in your data? Daily, right? At minimum, every time you do a release, right? And again, as we shift towards a serverless architecture, that release frequency is probably increasing, right? If you're the security and compliance people, how often do you go into it? Who here has actually done a security incident debug or actually root cause? One person, couple of people. How often have you guys done it on an annual basis? Once-ish a year, right? You don't get at that data very often, right? So now a tool for that, does it have to be very fast? It'd be nice, right? But if you have to spend a couple of days once a year, that's not the same as if every time you do a release, right, you have to have that type of latency getting into the data. So now I'll go into more like the actual details here on what to include in your logs, but at a minimum, these are the two things I tell people to make sure they log, right? Any error, right? I don't care if you handle the exception, but you darn well better log the fact that it was there, right? Likewise, any logins or other authentication events. And this is, the absolute bare minimum from an app support side and the absolute bare minimum from the security and compliance side, right? You have to know who was in and what was going on. In a microservices world, that can change a little funky, right? So every time I have an API key come in, that's actually technically an authentication event, right? That is a user that could have been spoofed. That is a password that could have been spoofed. You got to have visibility into that. You need to know if you're being abused or someone has broken through your security perimeter. Unfortunately, that does mean you're going to get a lot of logs. I don't know a way around that. And by the way, if people have questions, please. Yes. For those who didn't hear it, if you're logging authentications event, you do full fidelity on that. To the point that you can back it out to the individual account, yes. Right? So if that session key is useless, no, I would log a user ID. Right, so since I have that session key, that's going to get tied back to a user ID of some sort in your system, right? Because you have to know the context that you're executing under, right? And so that's the uniqueness that I would log. So more detailed logging recommendations, right? So, and this is really kind of more in the microservices type world, right? So ideally, right? And this is, again, going to be how much logging you can support on the back end. Every time you call a remote resource, log it. Why? Because that's your most likely point of bugs, all right? So that's going to be your highest value data coming back. The corollary to that there is if you can, right? And this, if you can't, this is probably something that's worth investing into. Include your call timings, right? And this is kind of back to my thing. You can put metrics in your logs. And if you have a good logging infrastructure on the back end, a logging platform, you can then go graph that, and you can implicitly get performance data, kind of by default out of your code. When you don't actually have access to the server under the hood, i.e. serverless, right? Or in some cases, a container world where you're not sure what your noisy neighbors might be consuming on there and how many megahertz, gigahertz you've actually been allocated at that point in time. This is a good way to kind of back into issues with your underlying infrastructure. The second one, and this is maybe just a criticism that I have it's a pet thing of mine. If you're modifying data, right, very useful to log the fact that that data just changed. Not always possible, in a lot of cases. In other cases, absolutely required, right? You can imagine if you're on Amazon and you're a seller, right, every time you change a price or you change an image, Amazon they've got a log of every one of those changes, right? On the other hand, there's going to be a more consumer-centric services that if you're going to change profile information or settings like that, maybe that's throwaway data. You don't actually care. If you can, log some delta about that data, right? This is what it was before. This is what it changed to. Particularly in the case if you're building something more like an Amazon.com, where that actually matters, right? Being able to reverse those changes and do a rollback if required by your data or your customers is a big deal. And it's also, from a customer support standpoint, a big deal, because at scale, and maybe not even that big of scale, people could be stupid, right? And they can change something, and then they're going to call up customer support, and they'll be like, "Your system's broken," right? No, you changed it, right? And that can help you maintain that better rapport with your customers, not go chasing red herrings when you didn't actually have a bug, and give you a way out of jail. The other big thing that I think is more and more important to log is your performance outliers, right? And so what do I mean by an outlier? So let's say you've got a remote system call. It's typically 150 milliseconds, 200 milliseconds, right? And you know that if it breaks, 800 milliseconds, you have downstream issues, right, with that stack. So log anything that gets close to that, right? So if your threshold for breakage is 800 milliseconds, maybe 600 milliseconds, anything over that, you log. Conceptually, this is just like your slow queries logs in databases. People are probably familiar with those, right? You'd set a threshold on your database. Any query that's over this, I'm going to log that query in here, right? And depending on your environment, maybe you're going to send alarms. Maybe you're going to do some after action type analysis on that data, right? But that's going to let you know that you've got a cliff that's in front of you, right? Or maybe a cliff for a certain type of actions before that code goes over that cliff, and now you've got wreckage on the floor. The last one here, and I've got a little bit of a Nginx example that's similar to this. If your logging framework kind of supports it, one of the things that's super useful to see in your logs is pre-aggregated data, right? So you can just kind of see a summary every 60 seconds, how many of call foo did we do, right? This is going to depend on your infrastructure and your logging libraries and some other stuff. Maybe it's doable, maybe it's not. But if you're the ops team or you're the dev that is trying to come in after the fact and figure out what changed, what broke, right? Being able to quickly kind of scan, summarize data like that, very useful. Other way to do it is if you have a logging infrastructure that can build graphs on the fly easily, you can sometimes get into the data that same way. So a couple different ways you can get into it. All right, so now let's say we've got all of our logging set up, right? And now we're on to debugging, all right? So here's the 3 rules in my world to kind of live by when you start debugging at scale, right? Figure out a Canary metric, right? And so just like we do Canary deployments to figure out if things are starting to break, right? You should have a couple of simplified metrics, right? They're not very specific, but they are generally indicative if things are good, if things are bad. And I've got some examples here that I'll kind of dive into. Understand the averages and, more importantly, the outliers of your system performance, right? So this is response time distribution graphs. That will tell you probably the most about how your application is actually operating at scale. The third one is not everything's a P0, right? Again, so if we're doing 10 million requests per minute coming in, and I've got 0.001% clients that are completely and utterly failing, that's problematic. If I'm having 100 per minute coming in, it's actually probably noise, right? I probably have more than that in terms of client that are having remote internet connectivity issues, remote system issues, whatever they are. It's not my problem. I can't fix it, right? And if every time I see one of those errors coming up, that's a P0 that's going into engineering, well, one, if you're the ops person who's sending that to engineering, that engineering team may take you out back, and again, you may not make it back inside, or at best, you're just going to waste a ton of time, all right? So work on aggregates, not individuals. All right, so Canary metrics. Early generation, so back to that slide where I had the 3 simplified versions of our deployment and systems architectures, right? If we roll back 15 plus years, we probably everybody had Nagios. Maybe you had, I'm totally blanking on the old RRD tool. Oh, RRD tool, there we go. That had your graphs and some basic system metrics. And we had our CPU utilization, we had our RAM, right? And we had our disk utilization. We're done, right? The reality was that told you most of what you needed to know to go figure out what was going on. Now, we got into more complicated deployments, and that gets a little harder to just say, hey, CPU or RAM, right? Because I've got a fleet, and if one's high and one's low, does that matter? Or, I don't know. So now we start going into things like requests per second, or, our request time, or we've got this new, not new anymore, AppDex, right? Which is, how, good my website is performing. These started actually morphing a little bit, and companies would start to figure them out. Those are some common ones. And now with like serverless and ephemeral, I don't actually think we know yet what those common Canary metrics are, right? So I've got a couple of ideas here that I think was where I would start, right, is doing this. And I'll freely admit I have not run 10 million requests per minute on a serverless architecture yet. But I think I'd start with invocations, right? Any throttling and any erroring, right? That's probably my first one. If that was not, if I was finding bugs that were not shown in that, I'd look at my execution times in each of those. That's probably a pretty good one. The latency on getting that serverless container spun up. And again, errors, right? Errors are a great canary coming through. So actually, I have a question for the room because I don't know the answer to this. Number 3 here. Anybody done large serverless deployments? I don't know if the serverless guys have worked on some, or what's the common Canary metrics there? Do you know? So this is a generally indicative metric that shows me the health. It's not going to tell me specifically where the problem is, right? But if I had Amazon.com, probably my page load time is my number one canary metric. My number two canary metric is actually probably sales per X, where X is a rate of time, right? And based on that, I'm going to intuit kind of everything else under the hood. All right, and then I mentioned averages versus outliers. All right, so this is a relatively generic number of requests over response time type graph. So these are going to change per application per use case, right? One answer is not going to fit all services. Be aware of that. You might want to set some internal organizational guidelines. It's probably the best way to put it. That what the contract is between all teams is that we should respond to general requests within X milliseconds. Right? That's a good thing to set between your teams. Right? Good common expectations, so you know how to build it. You don't get the pipeline, backing up or the workflow backing up. The other thing here, though, as much as I used averages and all this, whoops, I don't know where my step is there. Averages lie. Averages hide problems. Don't use averages at scale. Use percentiles. Percentiles are a whole lot better. 90, 95th, 99th, right? It's going to depend a little bit on your scale, your type of application, your variance, which one is really going to be better for you. Any of those is going to be better than actually just guessing on your average. Again, I'll keep using the 10 million per minute, right? You can have a lot of really slow responses hiding in that data. And if you're just looking at an average, you will never see them. I unfortunately speak from experience on this one several times, so don't share my pain on that one. And then the third one, it's kind of what I was just alluding to. Know your drop dead times, right? And so what do I mean by drop dead time? If your execution passes this threshold, bad things will happen. Know that. Particularly as you're going to microservices and you're decomposing this application across multiple systems and multiple interaction points, that's going to cause other issues back upstream of them if you start bumping up against those drop dead times. Again, I mentioned this before, log it as you get closer to that too, so you don't fall off of that cliff. Now, one of the things I mentioned is as we go to these microservices architectures, our system complexity under the hood keeps getting larger, and it gets more problematic to go deal with. And I'm going to bounce back up a step and say actually why that's a good thing. And so it's a good thing because in any given company, you're going to have 5 to maybe 10 engineers for every one operations person. And so if at an organizational level, you can say, hey, that 20% team, I'm going to make you a little less efficient so that the 80% team is more efficient. This is a good trade-off, right? Doesn't mean that it's free, right? As we should expect. And so how you deal with this and how you make that overhead as low as possible, right? Document. I know, nobody likes it. Draw diagrams, write wiki pages, do something to understand where, we were talking earlier, where you've deployed this function in Lambda and what function that is and what version it is and how to go get into that console, right? So when it breaks, you can go find it, right? You can understand what broke and where it's interacted. The second one is actually probably the biggest efficiency gain. If every engineer has to be aware of every different environment and how to go interact with it properly, one, they're not going to bother. It's going to be too time consuming. Two, even the best intentioned developers are going to make a lot more mistakes. And that's simply because if environment A doesn't match environment B, which doesn't match environment C, they have to remember the specifics of each environment every time they go in and change the code. That's hard. So build safety nets, or the belt and suspenders approach, right? Wrap your libraries. If you have said, which I think you should, every remote system call, we're going to log. Why should an engineer have to remember to go write that in their code? Go spin off a couple of engineers and go wrap your database libraries that you're using to connect to whatever remote system and log it implicitly. Now, they can add additional logging upstream of that if they want, but they're going to get a bare minimum coming through. Similarly, do it at the infrastructure level. So if you're running Kubernetes, get a daemon set running out in your Kubernetes infrastructure. It just grabs all your logs. If you're in AWS, dump everything to S3 and be sucking that back out. Whatever your infrastructure is, build a safety net underneath. And the last one, keep it simple, something. It's not new. It's fairly obvious. Just because you can do something a million different ways doesn't mean you should, right? Consider rolling that back, not using the latest and greatest tool set or framework every time you're rolling things out, so that you can support and you can be more consistent down the road. All right. 2 slides left, and I'll keep moving here. So what is this 3 things? If you'll probably notice, I like rules of 3 going through this, right? So these are the 3 things I think really to keep in mind as you shift into a Lambda or microservices type architecture. Documentation becomes even more critical, right? Just is. Invest in those safety nets. As you have more teams and more pieces moving around, the probability of people being well-intentioned and still making a critical mistake increases. Save them from themselves. Save you from yourself, so that when you're having to slam out a piece of code at 3 o'clock in the morning because you're late for deployment, you don't have to remember everything perfectly. And then make sure you have appropriate tooling, right? And this is, unfortunately, I have to be pretty hand-wavy because it's going to be fairly environment specific, that matches your scale, your work patterns. And real quick on what I mean by highlights of the tools, and I want to just completely hand-wavy on that, right? A good tool becomes a language by which different teams can interact with each other. When you describe a problem, you can speak with data. You can point to the same piece of data, and it doesn't become, as problematic with, if you game telephone, where things change when everybody hears it. Make sure that your tool is going to support structured queries, dashboards, and ad hoc. This is, again, back to your different stakeholders that you've got here. And when you get to scale, lots of data, right? Tens to hundreds of terabytes, or gigabytes, I shouldn't say. If you're big, I want to say eBay is about a petabyte a day on the back end there. So make sure that your tools scale to whatever your level of scale is going to be. And thank you.